Now, this question, alright, is from the 2015 exam paper. It looks quite complicated maybe to start off with, but it's actually not too bad. Okay, it's just to keep track of your different compounds as we move down through the question. So the first part of the question is what is meant by a mole of a substance, so that should be an easy 6 marks for you to get. So it's the amount containing as many particles as the number of atoms in 12 grams of carbon 12, or it's the amount containing Avogadro's number of particles. Okay, so the part we want to concentrate on are the calculation parts, so parts 2, 3 and 4. So how many moles of magnesium react with silicon dioxide to produce 7.6 grams of magnesium silicide? Okay, so that's just focusing on the top equation there. So how many moles of magnesium react with silicon dioxide to produce 7.6 grams? So we have the mass of our magnesium silicide, and we'll be able to calculate our relative mass as well. So from that then we'll be able to work out the number of moles of our different compounds. Okay, so our moles again is equal to mass over relative mass. Okay, our mass in this case is 7.6 grams. Our relative mass is actually 76 grams, so our number of moles is 0.1. Okay, and that's of your magnesium silicide. Okay, if we look at our equation, right, we want to find the number of moles of magnesium. So between our magnesium silicide and the magnesium, there's a 1:4 ratio. Okay, so for every 1 mole of this magnesium silicide, there are 4 moles of magnesium. So we're going to have to multiply by 4. So we have 0.4 moles magnesium. Now, if we move on to part 3 then, calculate the number of moles of hydrogen chloride required to react with 7.6 grams of magnesium silicide, and what mass of magnesium chloride is produced. So from part 1 we know we have 0.1 moles of magnesium silicide. Okay, and that's the same magnesium silicide as down here, so we have 0.1 moles of it down here as well. Okay, 1:4 ratio between this magnesium silicide and the hydrogen chloride. So again, multiply by 4, and it's going to come out to be 0.4 moles of that as well. Okay, so if we just write it down. So from part 2 we know that there's 0.1 moles of the Mg2Si. There's a 1:4 ratio. So again we're multiplying by 4, and there's 0.4 moles hydrogen chloride. Now, the next part of the question then says what mass of magnesium chloride is produced. So again, if we look at our balanced chemical equation, the ratio, so we know our number of moles of magnesium silicide, and the ratio between the magnesium silicide and the magnesium chloride is 1:2. So that means okay, so it's going to be 0.1 multiplied by 2 because there's a 1:2 ratio, and it's going to come out to be 0.2 moles. Okay, if we want to find the mass of it, Alright, again we're going to use our formula that we use again and again. Moles equal to mass over relative mass. So if we have our number of moles and we multiply by the relative mass, we'll find our mass. So in this case we have 0.2 moles. We're going to multiply by the relative mass of magnesium chloride, which is 95, and that gives us a mass of 19 grams of magnesium chloride. The last part of our question then says, what volume of oxygen gas measured at room temperature and pressure is required for the complete combustion of silane produced from 7.6 grams of magnesium silicide? Okay, so what volume of oxygen gas? Okay, so what volume of this oxygen here is required for the complete combustion of the silane produced from 7.6 grams of magnesium silicide. So that silane is this, it's the product of the second reaction. It's the other product of the second reaction. Okay, so up here we knew that there was 0.1 moles of magnesium silicide. 1:1 ratio, so we have 0.1 moles of this, of your silane. Okay, so that means down here as well we have 0.1 moles. You'll see here that there's a 2 before the oxygen, so there's a 1:2 ratio. So to find the number of moles of oxygen, okay, it's going to be that 0.1 again, multiplied by 2. So we're going to have 0.2 moles of the oxygen. To find the volume then, we in this case are going to multiply it by 24 litres because it's at room temperature and pressure. It's going to be 0.2 multiplied by 24, which is equal to 4.8 litres. Okay, and that's your final answer to part 4.